Example 2, writing a coordinate proof. So we are given the coordinates of the vertices of triangle POS and triangle ROS in the figure. We have to use this to prove that SO bisects angle PSR. So first of all, let's look at what we're trying to prove here. Angle PSR is sitting right there. And we want to prove that SO, which is right here, bisects the angle. So bisects, bi means two, means cut in half. Now, if something is cut in half, well, that means that you have two equal pieces. So essentially what we're trying to prove is we're trying to prove that this angle is congruent to that angle. Now, here's the game plan. I'm going to try to prove that this triangle is congruent to this triangle. Because if the two triangles are congruent, that means that all of their side lengths are the same and all of their angle measures are the same. And if all of their angle measures are the same, then we can conclude that this angle is congruent to this angle, which means that SO bisects angle PSR. Now, for our coordinate proofs, we're going to make these very informal. They're not going to be two column, and we're just going to kind of do like a bulleted list. So step 1, I want to prove that triangle PSO is congruent to triangle, let's see, RSO. And the way I'm going to do it is by side, side, side. So, side 1. I'm going to show that PO is congruent to RO. So, PO equals, and I can just count this out, 1, 2, 3. Do you notice it's back here at -3, which is 3, which equals RO, which is also 1, 2, 3, because this guy is out here at 3, 0. So that's the first side. You can just count it. That wasn't so bad. Side 2. So side 2, I'm going to do this one right here, which is in the middle, which is SO. So SO equals 1, 2, 3, 4, which is up here at 0, 4, which is also equal to SO, which we did using like distance, but you could have also just used the reflexive property because SO is SO. Now, our last side is going to be a little bit more difficult because it's slanted. So we have to prove that PS is congruent to RS. The way I'm going to do that essentially is the distance formula, but I like using the Pythagorean Theorem. So I'm going to start with PS, and we're going to find that. So PS is right here. I'm going to drop over this way. I'm going to drop up this way. This is a right triangle. So Pythagorean Theorem. I know this is 3. I know this is 4. So I can say that 3 squared plus 4 squared equals side PS squared. Because remember, a squared plus b squared equals c squared. So this is 9 plus 16 equals PS squared, which gives us 25 equals PS squared. Then in order to get rid of the squared, we're going to square root both sides. So I know that PS is 5. Now I have to show that PS is congruent to RS over here. So now RS, I'm going to do the same thing. So I'm going to drop this guy down. I'm going to drop this guy over. I know that this is 3. I know that that's 4. So 3 squared plus 4 squared equals RS squared. This should look very, very familiar. So 9 plus 16 equals RS squared, which gives me 25, and then square root. So we know RS is 5. So we now know that these are both 5. So step 1, we proved that the two triangles are congruent by the side-side-side theorem. So if the two triangles, we have this guy over here, is congruent to this guy over here, then I know, so step 2, that all of their angles are also congruent. So I can say now that angle PSO is congruent to angle RSO because corresponding parts of congruent triangles are congruent. Remember, that's what that big thing stands for? So now if I know that those two angles are congruent, remember we're trying to prove that SO bisects that angle, which means cuts it in half. Well, if the two sides are equal, then I know it's been cut in half. So now I can conclude that SO bisects angle PSR. And my reason is because of step 2, I know that those two angles are congruent.